Hello, everybody. Welcome to my channel, Island Daily. My name is Dr. Amen, and I'm an optometrist. And today we're going to learn how to read layers on optical coherence tomography. So let's get started. So first, I'm going to explain to you gross anatomy of the 10 layers of the retina, so I can later explain to you how to read those layers on OCT. So from going from the inside to the outside, we will have so we will have retinal pigment epithelium, right? So here you can see that retinal pigment epithelium has these small ciliated projections in which the outer segments of the pigment cells, rods and cones are going to lie. So we will also discuss the structure of rods and cones along with this anatomy. So here we'll have their outer segments. Based on the structure of their outer segments, they are named as rods and cone, right? Now, there is a small modified cilia which is going to join the outer segment with the inner segment, right? Now, there is a small body, cell body of these cells, right? And then we will have these Henle fibers. So, the synaptic cleft of cones is called pedicle, and of rods is called spherule, right? Now, so in the outer segments, we have these small plates in which the photopigments are going to lie, right? So we're not going to dive deeper into these pigments because now our concern is to just remember the structure and its layers, right? So So this was the structure of rods and cones along with retinal pigment epithelium. So these cone cells, these rod cells are going to synapse with what? They are going to synapse with the bipolar cells, right? Now, the bipolar cells are going to synapse with what? They're going to synapse with the ganglion cells, right? And now these ganglion cells will have their fibers, nerve fibers, which are going to make the optic nerve, right? Now, we also have some more nucleuses present along with the bipolar cells. So these are the bipolar cells. These are the ganglion cells, right? Along with these bipolar cells, we also have horizontal cells. Sorry. We're also going to have horizontal cells, which are going to synapse with the rods and cones, and also we will have amacrine cells, which are going to synapse with the ganglion cells, right? Also, we will have Wait, sorry. Also, we will have these glial cells bodies at the level of bipolar cells, right? And these are its fibers, right? So I'm going to label these all. These are the horizontal cells. These are the ganglion. These are, sorry, the amacrine cells, and these are the molar cells. Okay, now, now we are going to, now I'm going to describe how these layers are going to appear on the OCT. So first, I'm going to name all these layers. So this was the RPE, right? And this layer over right here is the outer segment and inner segment junction. So this layer is going to be called, let me choose another color. So this layer is going to be called IS-OS junction, right? Or the ellipsoid layer, right? And this right here is going to be called the external limiting membrane, right? This nucleus layer is going to form the outer nuclear layer, and this layer is going to make the Henle fiber layer, right? The point at which the rods and cones are going to synapse with the bipolar cell is called the outer plexiform layer, where they're going to make a plexus, a neural plexus, right? This is going to be the outer plexiform layer. This point over here, right here, where there are many nucleus present over here, is called inner nuclear layer. And this point right over here, where all these nucleuses are going to synapse with ganglion cells, and also there is this synapse going over right here with rods and cones. However, this point is over right here is called the inner plexiform layer, and this, as the name suggests, this is the ganglion cell layer, and these retinal nerve fiber layers are going to make the RNFL, retinal nerve fiber layer, and layer this layer is going to make the internal limiting membrane, right? So this was the gross anatomy. Now we're going to see how these layers are going to appear on the OCT. But wait, there's one thing I want to add. We know that at the at, at macula we will only have this point. We will only have cones. We will only have cones, and up to the Hessel-Henle fibers, we will only have this structure present at the foveola, right? And and at this point, which is called the clivus, at clivus, the ganglion cell is going to be 10 layers deep, right? So now, next we are going to see how it is going to appear on the OCT. So this is an OCT scan of macula. Now, this layer over right here is the Brooks membrane, which is the layer of choroid. And this right over here is up to this point, this layer, right? This is the retinal pigment epithelium along with the outer segments of the rods and cones, right? And this point, this layer right here is the ISOS layer, ISOS junction, or you may also call it ellipsoid layer, right? And this, you can see this small, very thin line over right here, this line, right? This very small thin line. What is this? This is the external limiting membrane, right? Now, after the external limiting membrane, we had the cell bodies of rods and cones, right? So these are the cell bodies. So what this is going to make? This is going to make the outer nuclear layer, right? And this right over here is this. These were the nucleuses, right? These were the nucleuses, right? And these are actually the Henle, this is the Henle fiber layer. Let's make it less messy, right? So this layer right here is the Henle fiber layer, right? Now, you can see at the foveola, we only have the nuclear layer and the Henle fiber layer and no other layer, right? So this very hyperreflective layer is called the outer plexiform layer. Okay, this is the outer plexiform layer where the rods and cones are going to synapse with the bipolar cells, right? Also with the horizontal cells. So this is a very thin line because this is only going to make a plexus, right? And this layer is the inner nuclear layer where all the nucleuses, where all the cell bodies are going to lie of bipolar cells, of amacrine cells, horizontal cells, and also of molar cells, right? And these cell bodies are going to synapse with what? They are going to make a plexus at, you can see this small plexus, a very, just like this layer, you're going to make a small thin plexus, and this is going to be called the inner plexiform layer, right? So they're going to make the inner plexiform layer, and then what? The inner plexiform layer is also hyperreflective, and the nuclear layer are going to be hyporeflective. They are going to have less reflection. So you can see this somewhat darker segment, right? Let me use a pointer. You can see this somewhat darker demarcation, right? This is going to be called the ganglion cell layer. Um, the ganglion cell layer, right? Now, this is, so this is the RNFL layer. So the RNFL layer is more on the nasal side. So even if you don't know which eye OCT scan you're reviewing, you just see where the RNFL layer is more thick, and you'll see, so it is more thick on the right side. So it is the scan of the right eye, right? So This is the ganglion cell layer, and this is the RNFL layer. You can see how thin it is on the left side, right? And if, right, this this is it. So you can see this very sharp and very bright, very thin line at the end. This is actually the internal limiting membrane, right? And this small, very grayish line, that is the vitreous. So we're going to we're going to document it as partial vitreous detachment, partial PVD, right? So these were the layers of retina. A very good tip for you guys is to read an OCT scan every day so that you can memorize these layers, and also so you can see any abnormality or any dysfunctioning happening in these layers. So that's it for today. I hope I have made everything clear. Thank you so much for watching my videos, and if you like my videos, give it a like and subscribe. Thank you very much.